Hello, everyone. Okay, feel like everything should be working now. So I had a change of laptop in the last second. Please let me know in the chat if you can hear me and see the terminal that I've got. Hopefully the font is all right. So let's get started. All right. Today I'm going to do a BGP cluster mesh with Calico, but I'm gonna do it in a very interesting way. I will be creating two VPCs in multiple regions of AWS. Then I'm gonna connect these two using VPC peering. Do some routing and go step by step through what are the things that you need to do if you want to do VPC peering, and what are the stuff that you might need to do if you are trying to establish a cluster mesh in a cloud provider environment. This is very important because in a cloud environment, you are not connected directly to each node, and usually nodes are using layer 3 routing in order to communicate with each other. All right. So without further ado, let's get started. Feel like just a second, I need to change something. All right, way better now. So let's get started. By the way, don't worry about the codes or anything. Every command that I run here will be in our GitHub, Calico Live GitHub repository. So let's just dive in and see what happens. First of all, there's a demo cluster, and hopefully I remember my password. Yay. All right. So there is a demo cluster project that I've created. This is basically a couple of examples of deployment, Calico deployments in cloud providers. I'm going to use Calico K3s-AWS. There's an example file for it. So I'm just going to copy that example. Hopefully I have Terraform. Nope, there are no Terraform. So I'm going to install Terraform now. Just a second. Thanks. So we do this. Install hasheet for. We do this. Verify fingerprint. Hopefully it is verified. Add the required thingy. Update apt. What's happening? And install Terraform. Yay. All right. So after copying the example, we do Terraform init. So Terraform init will pull all the modules and providers that a Terraform project is using. So here, as you can see, TLS, AWS, random, basic stuff. Let me just give you a better glimpse of this mysterious demo cluster. All right, so basically, this demo cluster project is just a bunch of Terraform configurations that will install Calico in different environments. It will give you private keys for SSH. It will set up everything in the middle, and there are a bunch of scripts that just installs Calico and like adds the worker nodes and stuff. So everything in the deployment part is taken care of, and you can actually focus on doing your own magic with Calico. Anyway, I'm going to change the encapsulation to IP/IP. This is because, as I mentioned, in a cloud provider, stuff are happening in layer 3, and the pod siders that Kubernetes have are not known to the cloud provider. So we need some sort of encapsulation to move this traffic between these nodes. Now that that is done, we can hopefully go ahead and prove. Oh, by the way, we're gonna need something else, which is, oh yeah. Since I'm using AWS, I'm gonna need some AWS authentication to happen. So let me just authenticate myself with all right, stuff happening. I got authenticated. Where are my files? Boy, oh boy, you change a laptop, everything goes haywire. Where are my credentials? Somewhere in here. Oh, AWS. All right. Let me download these files. All right. So credential and config. Now back in here, I believe it's MNT, so it's C. No. Go downloads credentials. Now this needs to go to config. Oh, let's just for now. And config. I need to actually, I do believe we could find it. Let's just fight the urge to show my credentials on a live stream, and don't do that. So main here, somewhere around here, there's a credential file, comes from variable. So it's AWS credentials. Huh? All right, so mkdir, let's do AWS. So, all right, exist. We do credential and config into AWS. Now let's go back to my demo cluster and hopefully things works. All right, some stuff are happening, some stuff are not happening. Oh, it seems like, all right, let me just authenticate with AWS. It's going to take a second. All right, it needs to be working. All right, let's go back here. Now, what is happening? All right, retrieving AWS account detail, color, status, get status, API, that token ID. Wait, do I have that token ID? Nope. All right, so AWS controls. Oh, so AWS. Let me just for a second. Did I change my credentials? There is authentication problems, left and right. Tigera. So all right, where is my token? Give me a token. Create access key. Just a second. So AWS config. All right. Access key. What is my access key? Oh no. Secret. Yeah. Yeah. All right. Let's just come back here. Let's do Terraform 5. All right. Things are good now. Finally, I'm authenticated with AWS. So let's just apply the Terraform Configuration. All right, so basically right now, my Terraform project will start to create two clusters, one in US East, the other one in US West. So if you look around here, you can see cluster B, cluster A. I believe cluster A is populated in US West too, and cluster B is in US East too. By the way, you can change these if you are in Europe, Middle East, Australia, wherever in the globe. You can change these by just coming to the by going through the main TF file in the demo cluster. Anyways, it's gonna take a bit of time for everything to be done. Oh, as you can see right now, it's just installing Calico. So it may be like 1 or 2 minutes more. Still creating. By the way, if you got any questions, please let me know. And hello, Viral. Hopefully I pronounced it right. From Romania. All right, so cluster A and cluster B are almost done. Since didn't have so commands are going to be available here after this live stream ends. All right, let's get back to the stuff that I was doing. All right, so we did make the thingy. Oh, I need to install JQ. All right, so let's just, nope, not PowerShell. Ubuntu. All right, let's install JQ since I'm gonna need it. Yep, JQ. And I believe that's about it. So right now, both clusters. Oh, it's doing the worker node. So it's just joining the worker nodes and it's almost done. Got the Calico cattle. Turn the dial on the worker. And still creating stuff. Done. All right. So after you are done with the deployment, it will give you a bunch of stuff. So cluster A PEM and cluster B PEM will be in your directory, working directory that you ran Terraform apply. These are IP addresses for each node. but I'm going to, for the sake of this thing to go correctly, I'm gonna put everything in environment variables so I just don't mistype. Anyway, I'm gonna use the cluster A IP address, the public IP address, to SCP and get the config file, Kubernetes config file out of it. Does some stuff. I do believe there is a CA config. Now I'm going to I'm going to need to change a couple of things here. First of all, this config file has the local IP address as the so as you can see, the server is 127.0.0.1. Now on the server that means something, but on my computer that doesn't mean anything. So I'm gonna change that to the public IP address and change the cluster name to cluster A. After that, I'm going to use two environment variable to store the IP address for control plane and the worker IP. All right, now that it's done, I'm gonna do the same thing, but this time for cluster B. Everything hopefully goes right. I do have two files, cluster A and cluster B config, so CB and CA config. Now I can export these two. So right now, Calico config will show nothing. What I can do is I can export kubeconfig and direct it to these files that I transfer. Now, if I do kubeconfig view, you can see I have two clusters and IP addresses are perfectly assigned to the public IP addresses of my AWS instances. Now, if you want to get information out of this demo cluster, you can always do Terraform output. It will give you all the IP addresses and stuff. And you could also do kubectl config view raw, whatever is needed to get information about that. All right, that being said, so let's start the cluster mesh thingy. So first of all, I'm going to enable BGP for my nodes. Now, the way I'm going to do it is I'm going to create a BGP configuration resource and assign an AS number to each node, each cluster. So cluster A is going to be 65001, and the BGP stuff are going to happen on port 179 because I want the other cluster to be able to communicate with the service IP addresses that are on cluster A. I'm going to also mention, you know what? Tell the other cluster about these IP addresses for the CIDR that is on my cluster B. And since it's a live demo, nothing gonna work. Let's just come back and do, I do believe it is skip. Let's just kubectl. What was it? It's an skip TLS something. kubectl get pods. Do believe it's skip TLS something. Let me just Google it. Kubectl skip TLS. What was the command? Oh, insecure skip TLS. All right, so nothing to worry about. We just need to add insecure skip TLS. Verify. All right. These demo gods are left and right giving me problems, and I solve it like there is no tomorrow. All right. Now next, let's just do something. Let's do an alias kubectl and actually say kubectl insecure. All right. So next, what I want to do is, oh, by the way, I just mapped kubectl to kubectl -- insecure skip TLS verify. So every time that I run kubectl, it will automatically add the insecure thingy in front of it. All right. Next, I'm gonna do the same thing, but this time for cluster B. If you're curious how to find the service IP address or the pod CIDR IP address, you could do kubectl cluster info dump on grep for CIDR. So cluster CIDR, service CIDR, everything is here. Cluster DNS, your cluster domain, everything. All right. Now next, I'm going to, now that we have BGP enabled, we do need to tell Calico or the BGP session, where are these other BGP peers? So what we can do is we can create another resource. So this time, again, I'm using -- context, which means use this cluster specifically for this command. So I'm doing a context cluster A. So that means this command will be run on the cluster A. Now I'm gonna build a BGP peer resource named BGP2 cluster. Not very important in this part. It's just a name to refer to it. However, then I'm gonna say peer IP. So peer IP is the device resource that talks BGP and I want to connect to it. Here is cluster B control plane IP address, and its AS number is 65002. Since cluster B got 2 nodes, I'm defining both in here. All right, so I got these 2 going for me. Let's build the same thing, but this time for cluster B. So again, the same thing, 2 BGP peer resources to tell cluster B where to connect for BGP, and the AS number for cluster A. If you're curious how to get these IP addresses, you could do get nodes. It will tell you what are these IP addresses, but if you remember at the beginning of this session, I put everything in environment variables to run into less problems. All right, so right now, if I take a look at the BGP sessions, I can do that, by the way. by using kubectl and invoking the BERTCL binary inside the Calico node. There are other ways, we'll get to it, but this is like one of the ways. So there are two BGP sessions, both are in the connect state. That means BGP is trying to communicate, but nothing is happening. So now it's time to figure out how to solve this problem. Well, if you look at our deployment, we can actually take a look at the deployment by going through the Terraform file. Cluster A is on US West 2A, 2B, 2C. And the CIDR block for the VPC is 172.16.00/16. So this means these two zeros will change to 255 and can change to 255. And these are going to be the IP addresses for resources that want to get IP address from that VPC. Now, if you look at cluster B, that one is on US East 2. And these nodes are, or these resources are a different subnet or a different broadcast domain, which is 172.17.00/16. Again, hosts are gonna acquire IP addresses from these two zeros. It goes to 255, IP subnet and basic networking stuff. All right. So how we can solve this problem? Well, we need to somehow establish communication between these two VPCs. Now, what I can do is I can actually use some AWS capabilities to actually connect these two VPCs together. Now, here is my VPC for US West 2. To make it easy, I'm going to again put these in environment variables. So I'm gonna take the ID for cluster A VPC and cluster B VPC. And these are going to be in environment variable cluster A VPC and cluster B VPC. All right, now that I have these two, I'm going to ask AWS to create a VPC peer connection between these two. Pretty simple. We just say AWS, please create VPC peer connection between my cluster A VPC and cluster B VPC. Now the peer region is going to be US East 2, and go ahead, do stuff for me. And VPC 2 does not exist, so it's great. Let's go back and figure out why that doesn't exist. All right, I got, wait, which one it said it didn't exist? I have to, all right, so VPC 79C, whatever, it doesn't exist. So is that, all right, so it says cluster A VPC doesn't exist. Let me just quickly check my AWS. I've got a VPC in US West. I've got actually 2 VPCs. All right. All right, it seems to be mistaken because these exist. So let's just perks of doing stuff live. All right, so cluster A, US West, and cluster B is US East. Are you sure about does not exist? All right. So VPC peer ID is cluster B. VPC ID is O. Wait. Is that because it's trying to? Nope. All right, I can do this in another way. So where is my peer connection? Number of tails. What is that thing that always comes in? All right. Peer connection. All right, let's just come here. All right, from here, I can do create peer connection, just name it something. And I wanted to connect my Calico VPC demo thingy on my account to another region. It's gonna be US West 2 and the VPC ID for US West 2 is going to be this thing. All right. I have no idea why it's being like this, but you know, things happen when you do stuff live. All right. So now that we created the VPC peering, we need to actually accept this request. For that, I need to go to the other side, check the VPC peering connection ID, check who's trying to request it, and accept the request. And done. All right. Now that I got that part going, let's go ahead and figure out the route situation. So again, I'm gonna run 2 commands to get the route ID into environment variables. After it's done, I'm gonna figure out what is the peer ID for the peer connection that I created. It's this thing. Now I'm gonna run a couple of commands to add routes. says RTB007 doesn't exist. Oh boy, they have problem with this VPC ID. So US best 2. Am I missing something with my commands? All right, let's just come here, route ID. All right, RTB43, whatever. So let's just do region US West 2. Huh. All right, that is the problem. Oh yeah, I know what is the problem. So my AWS config used to be default on US West. After I configured it, I forgot that. So now it is on US East. That's why a couple of my commands are not working. All right, I can hopefully fix that. Let me just. All right, so in order to fix that, I can do nano AWS config. All right, and do west here. All right, should be better. Now, if I do my commands again, it should work. Yep. All right, we fixed it. And the route already exists for the other one. Anyway, so let's just come back to what we were doing. All right, so after the peering connection is done, I actually need to tell AWS that for this connection, what are the resources that want to communicate with each other? So here, I'm creating a route in US West 2 for the route table ID of the ID of cluster A. I'm telling it that whenever resources in this VPC want to talk to 172.17.00/16, just, send them to that peer ID thingy. After it's done, you might be thinking that the BGP is going to work. Well, not entirely. So we did establish communication. However, everything in a cloud provider environment is secure. So that means you need to go into each VPC and open that port 179 for BGP communication. The way we can do that is, again, figuring out the security group IDs for both clusters, cluster A and cluster B, and then add security exception to allow port 179 to work. After that's done, you should be able to see BGP is established. So BGP established means if you check the routes in your cluster, you should see some interesting thing. So at the moment, our cluster knows about its default gateway, which is 000. So everything that it doesn't know how to get to will go to 000. The things that it knows about are 1052.203.0/26, which comes from global 172.17.1.222. And the IP address is 172.17.1.222. Now, this is an interesting value because I've seen it here. So our BGP is actually working, and these two clusters know how to get to each other. But if you try to send a communication, it will not work. And that's because, if you remember, in the beginning, I said, in a cloud provider, nodes are not connected together by layer 2 communication. And that means we need to provide encapsulation or routing for these workloads to be able to talk to each other. Let's just evaluate this idea. So this is a workload. I'm going to ping this workload that is on cluster A by another workload on cluster B. So as expected, it's not going to work, and I'm going to get timeout. Next, we need to, all right, so 100% packet loss. Great, that was something that we were looking for. All right, now how we can fix this issue? Well, in order to fix this, as I said, we either need to implement more routes on AWS, or we can do it the Calico way. So what we need to do is to go to cluster A and say, dear cluster A, if you want to talk to cluster B, service sider or pod sider, use encapsulation IP/IP. That's it. And we could do the same thing on cluster B. Remember, if you want to send traffic, both source and destination need to know where this traffic should go and where this traffic comes from. Now, since we are using encapsulation, we have to do one more step, actually 2 more steps. One is to allow IP/IP encapsulation to flow between these VPCs. So here I said, your security group, there's going to be an ingress on US East 2. It's going to be protocol 4, which is IP, and the CIDR that sends it to you is 172.16.0.0.0. Well, obviously you can change that to individual nodes or make it tighter, but this is the whole premise of what needs to happen. Next, I'm going to tell Calico to expect IP/IP from what IP addresses. So remember, there is some security measures both on AWS and Calico, because if there wasn't, everybody could like come into your cluster and willy-nilly ping stuff, which is never good. So here, I'm telling Calico that there's going to be some IP address from this CIDR to cluster A. Now, keep in mind, again, if you are doing this in a production, you need to change these to specific IP addresses. The tighter the IP address is, the better. So if you could do like /32, which is just like one IP, that would be great. Now, next, hopefully, if the gods are with me, should be able to ping something. Yay! All right. So at the moment, there is communication between cluster B workload and cluster A workload. That's all right. All right, so I successfully pinged cluster A workload from my cluster B. Now, there is one thing to mention here. By default, so this is only if you're using standard Linux data plane. If you're using Calico eBPF, you will not run into this issue. So by default, when you have a service, I need to get service. All right, get service nginx. Oh yeah. So by default, when you create a service, this external traffic policy and internal traffic policy are set to cluster. Now, if you want to access these services, you'll need to change that policy to local. Now, let's run an experiment and talk about why that is important to do. So if I do bin bash here, all right, and do a curl for that service, nothing is going to happen. Well, my pod knows how to get to that service. It cannot communicate with it, apparently. To fix that, all I need to do is to change that traffic policy for the external to local. With that, I come back and curl that IP, I will be able to get the nginx welcome page. And that, with all its, and that is it. Yeah. All right. So we established cluster mesh with BGP. We added VPC peering in AWS. I showed a bunch of secrets in the middle, left and right. And we talked about IP. If you got questions, please let me know in the chat, Calico Slack channel. If there are any other sort of issues that you run to, please come to our Slack channel. And that's about it. Have a good one, everybody.